Welcome to the video on area between curves and volumes of revolution. So first we'll figure out how to find the area between a function and the y-axis. So to find the area between a curve y equals f of x and the y-axis, you'll solve f of x for x and then find the integral from the initial y value to the final y value, like this. So if you had something like y equals x squared, and you were just looking at the positive x values and wanting to find the area between 0 and y equals 4. So this area here, you would solve this for x. So you would say x equals the square root of y, and then you would take the integral from y equals 0 to 4 of the square root of y dy. So that's how you would do that. So here we have an example that says find the area between f of x equals 12 over x and the y-axis from y equals e to y equals e to the fourth. So we'll start by solving this for x. So we have y equals 12 over x. To solve it for x, we'll multiply both sides by x. So we have x, y equals 12, and then we'll divide by y to get that x equals 12 over y. So now for our integral, it would be the integral from the initial value e to the final value e to the fourth of f of y, so x, which is 12 over y dy. So the integral from e to the fourth of 12 times y to the negative 1 dy. Our integral of y to the negative 1, or 1 over y, is going to be the natural log of y. So we'll have 12 times the natural log of y evaluated from e to the fourth. So this is 12 natural log of e to the fourth minus 12 natural log of e. So we can bring this exponent out front. So we have 4 times 12 times the natural log of e minus 12 times the natural log of e. The natural log of e is 1. So we have 4 times 12, which is 48, minus 12, which equals 36. So that's how you would go about doing that. Next, we have volumes of revolution. So a volume of revolution would be if you had some function like 1 over x from 1 to 5. You would have this area here. And then if you were doing a revolution about the x-axis, you would take that whole thing and you would rotate it around the x-axis. So it would look something like this. But when you rotate it, it turns it into a 3D figure that you could slice and find a bunch of circles. So essentially what you're doing is finding an area of an infinite amount of circles between here and here. So to do that, your area equals pi r squared. So pi r squared, and your radius is going to be whatever the function output is, because your radius would be the value from here to here. So you would have your area equals pi times f of x squared. So then we'll do the integral of that so that we can find the sum of all of those circles. So your volume is pi times your radius squared. So your radius here is your y value. So to get the volume, you're doing pi times the integral from your initial x value to your final x value of y squared dx. And then to find the volume for a revolution about the y-axis, your volume would equal pi times the x value squared, so your area, and then you're taking the integral of your area, or the sum of all the area, from y equals 1 to y equals 2 dy. So we'll do practice with this in our IB practice question. So here we have our first IB practice question, which is no calculator. It says, find the volume of the figure created when the positive portion of the function y equals negative x minus 4 squared plus 4 is rotated around the x-axis. So we have a quadratic. Our vertex is going to be when x equals 4 and y equals 4. And then it's negative, so it's been reflected. So if we want to find our zeros, we'll plug in 0 for y. So we get 0 equals negative x minus 4 squared plus 4. To solve for x, we'll subtract 4 from both sides. So we get negative 4 equals negative x minus 4 squared. Then we can divide by a negative to get 4 equals x minus 4 squared. Then we can take the square root of both sides. So we get plus or minus 2 equals x minus 4. So we have 2 equals x minus 4 and negative 2 equals x minus 4. Then we can add 4 to both sides. So we get 6 equals x and we get 2 equals x. So those are going to be our zeros. So if we graphed it, we have zeros at 2 and at 6, and our vertex is at 4, 4. So we're finding the volume created when the positive portion of the function is rotated around the x-axis. So that's when this portion here is rotated around our x-axis. So we'll get that same thing down here. And then it'll form something that kind of looks like an egg shape. So to find the volume, our volume will equal pi times the integral from our first x value to our second x value. So from 2 to 6 of our function y squared. So of negative x minus 4 squared plus 4 all squared dx. So now we just work on simplifying this integral. So we'll have pi times the integral from 2 to 6 of negative x minus 4 squared, so x squared minus 8x plus 16 plus 4 squared dx. Then we have pi times the integral from 2 to 6 of negative x squared plus 8x, and then we have minus 16 plus 4, so it'll be minus 12 all squared dx. So we'll work on squaring the function over here. So negative x squared plus 8x minus 12 times negative x squared plus 8x minus 12. So we'll start by multiplying negative x squared by everything in the second parentheses. So this will become positive x to the fourth minus 8x cubed plus 12x squared. Then we'll multiply 8x by everything in the second set of parentheses. So we'll get negative 8x cubed plus 64x squared minus 96x. And then we'll multiply negative 12 by everything in the second set of parentheses. So we'll have plus 12x squared minus 96x plus negative 12 times negative 12, which is 144. So we'll combine our like terms. So we'll have x to the fourth, then we have negative 8x cubed and negative 8x cubed, so that's negative 16x cubed, then plus 12x squared plus 64x squared and plus 12x squared, so that's plus 88x squared, and then we have negative 96x and negative 96x, so negative 192x plus 144. So we'll go ahead and put that in place of this here. So we have pi times the integral from 2 to 6 of x to the fourth minus 16x cubed plus 88x squared minus 192x plus 144 dx. So this equals pi times the integral of x to the fourth is 1/5 x to the fifth. Then we have minus 4x to the fourth plus 88 over 3 x cubed minus 96x squared plus 144x evaluated from 2 to 6. So we'll go ahead and plug in 6 and then we'll minus the same thing with 2 plugged in. So we'll start all the way over here because it's going to be long. So we'll have pi times 1/5 times 6 to the 5th minus 4 times 6 to the 4th plus 88 over 3 times 6 cubed minus 96 times 6 squared plus 144 times 6 minus pi times 1/5 2 to the 5th minus 4 times 2 to the 4th plus 88 over 3 times 2 cubed minus 96 times 2 squared plus 144 times 2. So our 6 squared is 36. 6 cubed is that times 6, which is 216. 6 to the 4th is that times 6, which is 1,296. And 6 to the 5th is that times 6, which is 7,776. We'll do that same simplification with our 2's. 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, and 2 to the 5th is 32. So this equals pi times 7776 over 5 is going to be 1,555.2 minus 1,296 times 4, which is 5,184, plus 88 times 216 over 3, which is 6,336, minus 96 times 36, which is 3,456, plus 144 times 6, which is 864. So we have that minus pi times 1/5 times 32, which is 6.4, minus 4 times 16, which is 64, plus 88 times 8 over 3, which is 234 and 2/3. So we'll just write 234 and 2/3, minus 96 times 4, which is 384, and then plus 144 times 2, which is 288. So then this equals pi times all this together, which comes out to 145.2, minus pi times all of this, which comes out to 81 and 1/15. So we have 145 and 1/5 minus 81 and 1/15. So we get pi times 145 minus 81, which is 64, and 1/5 minus 1/15 is 2/15. So this equals 962 pi over 15. So since it's volume, we would say 962 pi over 15 units cubed. So if they were to give you this with no calculator on the actual test, they probably wouldn't give you numbers that are this difficult. But this is just for an example of what you would do. So now we have our second IB practice question. It says, find the volume of the figure created when the function y equals -x plus 4, where 0 is less than or equal to y, is less than or equal to 4, is rotated around the y-axis. So this time we're rotating it around the y-axis. We have y equals -x plus 4. So our y-intercept is 4, and then our slope is -x. So you go down 1 over 1. So it's going to hit our x-axis at 4. And we're going from when y is 0 to 4. So we're rotating this figure here around your y-axis. So it'll look something like this. It'll be a cone. So we'll start by solving this equation for x. So we have y equals -x plus 4. We'll subtract 4 from both sides, and then divide by -1. So we get -y plus 4 equals x. And then we have our limits of 0 and 4. So our volume will equal pi times the integral from 0 to 4 of x squared, so -y plus 4 squared dy. So this equals pi times the integral from 0 to 4 of negative y plus 4 squared, so that becomes y squared minus 8y plus 16 dy. So this equals pi times 1/3 y cubed minus 4y squared plus 16y, evaluated from 0 to 4. So it's going to equal pi times 1/3 4 cubed minus 4 times 4 squared plus 16 times 4 minus pi times 1/3 times 0 cubed minus 4 times 0 squared plus 16 times 0. So these things here are all multiplied by 0, so it's going to be 0, 0, and 0. 4 squared is 16, and 4 cubed is 64. So we have pi times 64 over 3 minus 64 plus 64. So negative 64 and positive 64 would become 0. So this equals 64 pi over 3. And it would be units cubed. So we can double check this one because it is a cone. The volume of a cone is 1/3 pi r cubed. Our radius of our cone is the radius here at the base, which would be 4. So this would be 1/3 pi times 4 cubed, which is 64. So this is 64 over 3 pi units cubed. So we know that what we did here was correct. So in summary, to find the area between a curve y equals f of x and the y-axis, you'll solve f of x for x, then find the integral from the initial y value to the final y value. To find the volume of a revolution about the x-axis, you'll do v equals pi times the initial x value to the final x value of y squared dx. And to find the volume of a revolution about the y-axis, the volume will be equal to the integral from the original y value to the final y value of x squared dy. That's all for this video. Thank you for watching.